Good morning, Math 10s. We're moving on to the second lesson of the measurement unit, and lesson 2 is on surface area. This is going to be one of 2 videos, so it's a longer lesson, and I will split this lesson into part 1 and part 2, so this is going to be part 1. Okay, to start with surface area, when I say what is the surface area of an object, and let's say I gave you this object here, and I say, okay, I want you to calculate the surface area. What I always tell students to imagine is imagine that you're painting the object, and your paint only touches the outside of a three-dimensional shape. So you'd be figuring out, well, what's the area of this rectangle? And then figuring out all the different rectangles, what the area is, and adding them together, right? So if you were painting this object, how much paint would you require? That would be a surface area question. So maybe just jot that down. Imagine you're painting the outside of an object. Surface area, it's measured in square units. So this is sort of the first important thing. I'll give you an example. With this rectangle, if I said calculate this area of the rectangle, you would say, okay, the area of a rectangle, the formula is length times width. And let's say that this was 5 centimeters by 3 centimeters. Then the area of the rectangle would be 5 centimeters times 3 centimeters. You know that 5 times 3 is 15. And then we need to state our units. A centimeter times a centimeter, I've got 2 of them. It would be a centimeter squared. So the first important thing is if I'm asking you to give me a surface area question or an area, your answer always needs to be in square units. So centimeters squared, meters squared, feet squared. And let's say I actually don't give you units, you would still write, okay, your answer in units squared. Okay? These 3 shapes here, I just want you to sort of make a note on this page. These are the 3 shapes that the formulas are not provided for you, and you just have to know these. You have to memorize these. The reason why the rectangle, the triangle, and the circle has to be memorized is any sort of information or material that you did in junior high, it's considered that you have to know that already for high school. So because these 3 were done in grade 9, you would be required to know them on a test and they won't be on your formula sheet. For this lesson, you definitely want to have your formula sheet in front of you because we're going to be, for this lesson, doing surface area, and we're going to be going through these shapes here. And then here are the formulas for these shapes. Lesson 3 will be on volume, and here's the formulas for volume. Okay? Okay, so let's just quickly write the formula for the area of a triangle. So area of a triangle is base times height divided by 2. So that's just expected that you would know that. So again, let's say they gave you that the base of this triangle was 10 and the height of the triangle is 5. Then you would say, okay, the area of the triangle is base times height, which would be 10 times 5 divided by 2. Always do your numerator first. So 10 times 5 is 50 divided by 2. The area of this triangle would be 25 units squared. For a circle, the area of a circle is equal to pi r squared. And r is the radius of the circle. And remember, the radius of the circle is the distance from the center of the circle to the outer edge of the circle. That would be the radius of the circle. What they'll often ask in measurement questions is they'll give you a picture and they'll say, oh, okay, the diameter is equal to 20 centimeters. So the diameter is the distance across the entire circle. If they gave you that and said, well, what's the radius or what's the area of this circle, you would need to know what radius is. So you would just take 20 and divide it by 2, and the radius would be 10 centimeters. Okay, the first object that you need to know, it's called the rectangular prism. Here's the surface area, or here's what a rectangular prism looks like. And where this is on your formula sheet is right here. So the surface area of a rectangular prism, it looks quite complex, but I'll show you how to break it down nicely. So what happens is the surface area of your rectangular prism is using this formula here, and you just have to, on your shape, write down the length, the width, and the height. So this 5 centimeters here, that's the height of my rectangular prism. The length and the width, these two are interchangeable. So it doesn't really matter which one you say is the length, which one you say is the width, as long as you're consistent with your plugging it into your formula. So I'm just going to say that I'll just do length and width is what I'll do. Okay, so the surface area of this rectangular prism, 2 times length times width. So 2 times 3 times 4 plus 2 times length times height. So length again is 3 and height now is 5 plus 2 times width times height. So width I denoted as 4 and height I said was 5. Okay, so let's figure out what this would be. So continue to write surface area. 2 times 3 times 4 is 24. 2 times 3 times 5 is 30. And 2 times 4, 5 is 40. You aren't actually required to put units until the very end, and I often tell my students to omit units until the very end because you just will have too much writing if you include units in your intermediate steps. Surface area is equal to 24 plus 30 plus 40 is 94 centimeters squared. And that would be the surface area of that object. Okay, so that's the first shape that you need to be able to calculate. The second shape that you need to be able to calculate is a cylinder. So what I want everybody to do is look at your formula sheets and see if you could find cylinder, because a lot of this just is being able to locate the shape on your formula sheet. So if I go down here, here's where it says cylinder, and it says surface area is equal to 2 pi r squared plus 2 pi r h. So I'm going to write that down, and then we're going to break this formula down. So the surface area of a cylinder is equal to 2 pi r squared plus 2 pi r h. Okay, so write that down, and I'm going to deconstruct the cylinder, and we're going to talk about, because you need to know where these two parts come from, because in some questions you might only be required to use one of the parts. So if I said, okay, what does a cylinder break down into? It has a top circle and a bottom circle, and you need to, from that previous slide, know the area of a circle, right? So if I go to that first slide on what you need to memorize, you need to have memorized this pi r squared. So let's write in each circle the area of the circle. And the area of the circle is pi r squared and pi r squared. So 2 pi r squared, this part of the formula, that comes from the two circles, right? So for example, if I said, I want you to paint this cylinder for me, but I only want you to paint the top and not the bottom, how would you change this formula? If I said paint the top and not the bottom, instead of 2 pi r squared, if I only want you to paint one circle, you would change that to 1 pi r squared, right? This piece here is called the wraparound part. So this piece here is what we call the wraparound part. This would be like the label on a can. And we want to have a more, a better term, a mathematical term for the wraparound part, and there is one. And that technical term, that is called the lateral surface area. So this, in the formula, 2 pi r h, that would be the lateral surface area, and that is the wraparound part. So the reason why it's so important to understand how this formula breaks down is because, again, I could give you a cylinder like this question here, and I could say, I just want to know what would the lateral surface area be. You have to understand, okay, lateral surface area is just that wraparound part. And if I said on this question, what's the lateral surface area? This is what you would do. You would say, okay, surface area is equal to 2 pi r squared plus 2 pi rh. And then you would write that formula down. And if I said calculate only the lateral surface area, that's the wraparound part, you would completely omit this, right? So you need to be able to understand how to manipulate your formula and only use pieces of your formula. Example 2, what is the area of the following cylinder to the nearest hundredth square foot? So hundredth is 2 decimals, and they want the surface area of this entire cylinder here. So imagine that we're painting the entire thing. We are going to use both the 2 circles plus the lateral surface area. So we're going to use the entire formula. So surface area is equal to 2 pi, r is my radius, and my radius is 6 feet, plus 2 pi, my radius is 6 feet, and the height of this cylinder is 9. Surface area is equal to, the nice thing about this formula, it's nice and easy to punch in one string on your calculator. So 2, you want to use your pi button, r squared, and r was 6, close that bracket and square it, plus 2, your pi button, the radius again was 6, and the height is 9. There's my answer. They want it to the nearest tenth, or sorry, to the nearest hundredth. So that means I want it to 2 decimals, and I would say, okay, you need to round this to 2 decimals. This rounded to 2 decimals would be 565.49. So surface area of cylinder, 565.49. At this step is where I would add your units. So to the nearest hundredth of a square foot, and because it's surface area, I must square that. Again, here's just a note for lateral surface area. Lateral surface area, wraparound part. So wraparound part. Okay, right pyramid. So let's go to our formula sheets and let's find the formula for a right pyramid. So if I go here are all of the shapes that you need to know for this and see. Here is the right pyramid. And what's kind of interesting about this is it doesn't really give us a nice formula. So I'm not actually going to write anything on here. What we're going to do is we're just going to say, okay, how, if we were painting the shape, how would we do that? Now, before we do that, I want to go through a couple of things on your right pyramid. The peak of your pyramid, that's called the apex. Okay, this height here, that is the height of our pyramid. This is the base of our pyramid. And then this triangle is the face. And there's 4 faces on this pyramid. There's 4 triangles. So if we were calculating the surface area, we'd have to calculate the area of one of those faces, right? Later to know, okay, so there's 2 different heights in a pyramid. There's the height from the center of the apex to the center of the base. That is the height of the pyramid. And then on your triangle, so on this triangle here, there is a height of your triangle, right? That would be the height of the triangle. And we refer to that as the slant height because that height is at a slant. Okay, so if I said, what's the actual height of the pyramid, I said, what's the height of this triangle? It's at a slant. That would be the slant height. Okay, so just as long as you understand that. Okay, because the formula on the formula sheet doesn't look too nice, let's pretend that we're going to be painting this object. And I said shapes that we need to paint. What you have is you have a square down here, and they tell me that it's a square. And then you have 4 different triangles that wrap around. So if I was to, this is called the net of the pyramid. If I was to open up this pyramid, I would have 1 square and 4 different triangles. If I said, well, paint this, what would you be painting? You would be painting the base, which is the area of a square, right? So what's the area of a square? Length times width, which would be 8 times 8, because this is also 8. And 8 times 8 is 64 centimeters squared. So that's the area of the square. And then to this, we need to add these triangles, right? We need to add these triangles. So let's calculate the height of, or the area of one of the triangles. Let's say I said paint this triangle here. So the area of a triangle is equal to base times height divided by 2. So the area of one triangle, here's the base of the triangle, which is 8. Here's the height of the triangle, which is 10. And then you divide that number by 2. Area of one triangle is 80 divided by 2. So therefore, the area of one triangle is equal to 40 centimeters squared. You need to ask yourself, how many triangles are you painting if you're painting this 3D object? And you should say that there's 4 of them, right? So there's 4 triangles. So 4 times the area of one triangle is 4 times 40. And the area of 4 triangles is 160 centimeters squared. Now, if I said, okay, well, what's the surface area of this rectangular prism? What's the surface area of this object? I'm hoping that you would see and say you need to take the base and add it to those 4 triangles. So the area, the surface area of this object is the base plus those 4 triangles. So the surface area of this rectangular prism is 64 plus 160, which is 224. Put your units, they told me it was centimeters, and because we're dealing with surface area, all surface area is squared. Okay. Um, the right cone, so if we were painting a cone, let's find the formula for a cone on our formula sheet. So on our formula sheet, the surface area of a cone is pi r squared plus pi rs. So let's write that down and break it down. So surface area of a cone is pi r squared plus pi rs. Pi rs. Okay, so if I said we need to paint this cone, what would your paintbrush be touching? It'd be touching 2 separate things. I hope everybody could see that all cones have a base, and that base, what's the shape of it? It's a circle. What is the area of a circle? Pi r squared. So a cone has 1 circle. And when I say paint this, pretend this is like a wooden cone, like a 3D wooden cone that you're painting the entire thing, and you're able to paint that bottom circle. So when we break down this formula, what would this pi r squared be? Well, a cone has 1 circle, so that's the circle of the cone, or the base of the cone. This would be the wraparound part of the cone. right? Pi rs would be the wraparound part. So that, what did we call the wraparound part? That is the lateral surface area. And again, why it's important for the cylinder and for the cone to be able to understand how to break this down is because let's just say this was a ice cream cone and I said, how much paint would you need to just paint the ice cream cone? You would not use this, right? You would not use that circle because if it was an actual like ice cream cone, you wouldn't be painting the bottom of the circle. You'd just be painting the outside of it. Okay. For this example though, calculate the surface area of the cone to the nearest tenth. They want us to calculate, pretending we're painting the entire object. So let's rewrite the surface area of a cone, pi r squared because there's one circle, plus pi rs. S, you guys, stands for slant height. That's what S stands for. So it would be this height of the cone here. It would not be this height. That's going to be for volume. Okay, so that red height will be for volume. But if we're doing because we're painting the actual outside of the cone, you need to get the slant height, which would be this guy here. Okay, pi r squared. They give me the diameter. I need to calculate the radius. So take that diameter and divide it in 2. And the radius of this cone would be 13.5 centimeters. Okay, so the surface area of this cone is pi 13.5 squared plus pi 13.5, and the slant height is 40. Let's type this together in our calculator. So if you have your calculator at home, take that out, punch this in with me. Second function, type in pi. In a bracket, type your radius, and outside of your bracket, you're going to square that. So pi r squared plus the pi button, the radius, and the slant height. And again, you could type it nicely in one string in your calculator, hit enter. This question says they want the answer to the nearest tenth. That means 1 decimal they want included. So I would not round that 0 up to 1. It would say as a 0. So my surface area is 2269.0. 2269.0 centimeters squared would be the surface area of my cone. That is going to be the end of part 1. I will do spheres on the second part. I want you to flip now quickly to your homework, and I'm just going to discuss what questions I want you to do. So the homework questions, these are your questions here. But if you flip to this page here, I'll circle what I want you to do. So question number 4, determine the lateral area of each right pyramid. So remember that lateral area is just the wraparound part. And if I said, well, what would the wraparound part of this pyramid be? It would be those triangles, right? So it would be, imagine you're painting this pyramid not including the base. So don't include the base. So all you need for number 4 is the area of a triangle. It's base times height divided by 2. Area of a triangle. The base of this, because they say it's a square, it's 6 by 6. So 6, the height of the triangle is 11 divided by 2. So when you do this on your calculator, make sure you type in your numerator first, and then you hit enter, then divide it by the denominator. Okay, that will give you the area of one triangle. But remember, this pyramid has 4 triangles. So once you get the area of one triangle, get the area of all 4. So I want you to do question 4. Then you're going to do question 5, which is this exact same picture, but it wants you to now add the base. So it wants the surface area of this entire pyramid, including the base, right? So you're going to add the surface area of the base plus those 4 triangles. You could do number 6. Okay. Again, lateral surface area. That's just the wraparound part. So again, if I was to go to your formula sheet for a cone, pi r squared plus pi rs. So let's write that down. So surface area of the cone is pi r squared plus pi rs. You have to be able to know which one was the, well, I know that that's the surface area of a circle, right? So the lateral, the wraparound part is not including the circle. So for number 6, you're not going to use that. And you're going to use just pi rs. For number 7, I want you to do this for homework. You are going to do the entire formula because it wants, pretend now you're painting the whole cone. Pi r squared plus pi rs. Okay, so do 4, 5, 6, 7. You could do number 9. You're sketching it. And you could do 11A. So 11A. And all of your solutions are right here. Okay,